I've already done in part 1 A and B, and I'm going to do C, D and E, which are quite long sections and are going to involve quite a few marks, and we're definitely going to need the graphic calculator. So I've already established that I've got a normal distribution, mean is 20, and the standard deviation is 1.5. So what I want to do on this one, a widget is chosen at random, find the probability its overweight is 0.7. I'm going to draw a quick diagram. 20 in the middle, excuse my shaky drawing. And this is A because 70% are overweight. 70% of them must be bigger than A. And I can do this directly from my calculator. The diagram's probably enough working out. So we're going to get the calculator up and we're going to use the inverse normal again, which I already had selected. If you didn't know how to select it, you go to distribution, normal, inverse normal. My area is to the right. Tail is 0.7. And I want to change this. I want to use 1.5 for the standard deviation and 20. So I can actually use the data that I've got there. And we're going to execute that. And we get 19.21. So A is 19.21. Now, a widget is chosen at random from the overweight widgets, so I'm only choosing from within this group. Find the probability that the widget weighs more than 22 grams. So what I'm going to do is I'm actually going to find the probability of the widget weighing more than 22 grams. So let's make another diagram. (20) in the middle, 22. And just find this area. Now again, very straightforward on your calculator. Distribution, normal. I'm looking for an area, so I use this one. My lower area is 22. My upper area, I'm going to make it something big. And I've already got these put in there, so I get that as 0.912. 0.912. So this is 0.0912. That's the probability is bigger than 22. But I am going to divide it by 0.7 because a widget is chosen at random from the overweight widgets. This is the probability of it being over 22 from the whole selection, but just from this bit, we have to divide it by, I think that was 19.2 or 19.1. We have to divide this by the whole 0.7, so it's this bit out of 0.7. Now that comes out as 0. We'll just double check this on the calculator, but I think it's 0.1303. 0.92. 1.2 divided by 0.7. 1303. Okay. Now, 3 marks. This one's worth 5 marks, and this is very common in IB, that they started you off with a normal distribution, but this ends up being a binomial distribution. So we've now got a binomial distribution. Now with a binomial distribution, you want n, how many there are being done, and p, the probability of the success. So 6 widgets are chosen at random from a large selection of overweight widgets. Find the probability that at least 2 of the widgets weigh more than 22. I already know the probability of a widget weighing more than 22 out of that selection as 0.0912. 0.1303. Find the probability that at least 2 of the widgets weigh more than 22. Now, I know it's binomial, by the way, because it's either overweight or it's not overweight, or over 22 rather, or under 22. Now, what I'm looking for is the probability that x at least 2 weigh more, so greater than or equal to 2. So in other words, 2, 3, 4, 5, 6, etc. Now, with this information, again, I want to go straight to my calculator. So let's call the calculator up again. Let's keep that information on the screen. And let's get exit. Actually, we need a menu to distribution. Now, this time it's become a binomial distribution. And I am looking for a cumulative because I want more than just one value. So it's BCD. And my lower value is 2, my upper value is 6, and I'm doing 6 trials, and the probability of success is 0.1303. So just take a good look at that. That comes from these 2 bits of information here. Lower is 2 because I want 2, 3, 4, 5, 6. I'm doing 6 trials, and there's my probability. Click that, and let's get an answer. 0.178. So 5 marks for that.